Hey there, future aviators. Today with Alexei we'll go over aviation weather. I have to say that is one of the most complex, deepest topics that I've studied in my aviation journey, but at the same time I think it is on the instructor to make it simple. There's only so much that you need to learn at first, but expect you will be learning that as you go in your aviation career. Depends how far you'll get. So why are we learning this and what for? The plan is by the end of this lesson, we'll get Alexei or any other student to be able to source and interpret aviation weather. So I want you to be able to find it and to make sense of it. At the same time, understanding basic weather phenomena would be great. What affects flight safety, like what's the worst kind of weather phenomena that you may see, what matters more and what matters less. And at the end, that impacts your go, no-go decisions. The purpose of this exercise overall is to be respectful and knowledgeable about weather. It is one of the most hazardous aspects of flying for VFR pilots. At the same time, we don't want to simply quit flying when the weather is anything but perfect. Especially here in Oregon, we get a lot of clouds. Which clouds are worse and how to predict them. That's the scoop. But again, I want to make it simpler. Which, again, at the end, you let me know if I was able to do that. We'll go over METAR and TAF. Those are your primary sources of information. METAR is the meteorological conditions at the time and at a specific place, and TAF is the terminal area forecast. That's your future outlook. There are some convenience tools that I'll throw in right away, which, again, 20 years ago they weren't those kind of tools. Now everyone has a phone, and guess what? There is an app for that. PIREPs, Air Pilot Reports, NexRad in Next Generation Radar. There's a lot of good imagery that helps you to get that advanced kind of weather briefing. Weather depiction and surface charts. In your tests, in your private pilot exams, you will be asked to interpret some of them, so we'll go over basics. As well as METAR plot charts, winds aloft. We'll talk about what SIGMETs and AirMets are. And there is a advisory circular, which I highly recommend to read. I know, Alexei, you like reading, so stand by for some good read recommendation. Okay, let's jump right into this. Weather sources. Not so long ago, a ForeFlight became available, and then it really became the mainstream. I'm sure you've heard about ForeFlight by now, and I highly recommend the moment you'll fly at least any significant amount of time, it saves you a lot of hassle and efforts on getting all kinds of information. But even outside of ForeFlight, the usual existing services that people were using, they still remain. There is a website, the 1-800-WX brief, the weather brief, and they have the phone service. The phone service is really, you shouldn't hesitate to call it, use it, but I find it mostly useful when weather is marginal. If you are looking to fly, say, in Hillsborough to Astoria, but you see that there are some clouds on the forecast and ceiling isn't all that clear, you call them and they would dig into details for you. They do that every day, 1,000 times a day. They really know what they're doing, and when you need an expert advice, you call the 1-800-WX brief. Now, for the basic information like TAF and METARs, one of the interesting sources that is available, I'm not sure how long ago it became so, is the text service. You can literally text message to that 358-782 number, FLT SVC, flight service, and I'll show you a picture on the next slide, and it comes back with a TAF or a METAR for the airport that you need. But there are websites, and I'll have pictures from several of them. Aviation Weather website, aviationweather.gov, that has a lot of imagery forecasts. And so again, back to my original comment, there's so much about weather, there's no chance we can fit this in the 40 minutes. My goal is to, number one, set you up with the basics that you will be using no matter what. And second, set you up with the next education, what to look into. And when you'll be taking class in ground school, I'm sure what they cover will be additional to what we'll be able to cover today. So, back to the slide. Couple websites, Aviation Weather, and NOAA, and the flight service, the 1-800-WX Brief. At least those three, they would get you covered. They provide a lot of what you'd be looking for. And just for the terminology's sake, the types of the briefing. When you call for the briefing into WX Brief, you would either request a standard briefing or abbreviated or an outlook. Kind of going from the bottom up, if you are planning a flight 3 days out, you ask for an outlook briefing. There'll be less detailed forecasts, but you get an idea what to expect. Then the day off, you'd get a standard briefing, which includes a lot of information, and that is your main planning source for the flight. And if weather is unstable, if it's changing, maybe just before starting an engine, you can get an abbreviated briefing that just lists, they would give you what changed from the standard briefing that you got some hours before. So here's a big picture, and just before we dive in details, let me know if this makes sense, if you've seen about any of those, if you have any question about specific lines, products.
Haven't seen any of those yet, but looks exciting.
Okay.
So the weather brief, is that like pre-recorded or it's custom for you?
Good question. Yeah. So the weather brief in when you say weather brief, you can refer to the fact of getting all this weather information in one place, or if you are referring to the phone service, that 1-800...
like the phone service, the 800 number, for example,
yeah,
or the website.
You get through to a real person who will ask, what's your flight route, what's your tail number, what's your name, probably, can't recall, and you will ask them real questions and you'll get real human answers. You're welcome to drive them towards what you need to do, and they're very helpful and very human, so that's worth a try.
Yeah, that's cool. Awesome.
Yeah, all available and free to use for anyone who wants it. So real awesome service.
Our tax money at work.
Exactly, yes. Okay, now let's dive into one by one into those. Meters. It's a textual encoded observation on a specific location. Typically issued each hour or as needed. The speci is a special, so when something changes dramatically or really requires an urgent update. Typically what you're looking for is the ceiling, winds, dew point, and then temperatures, and anything extra altimeter is definitely of help. Now the example, if you see the example line here, that is your actual encoded line that you will get, and at least some of the descriptors or qualifiers are in this table below, the ones that are most common. Now, probably the first 5 parts represent majority of what you start with. The airport name, in this case is KGGG, then the date and time in the format of the day of the month, and then the time in the UTC format, then winds, 140, speed 21, gust 26, visibility 3/4 mile, and then we go into the weather phenomena with acronyms. So plus in this case means a heavier than normal, TS is a thunderstorm, RA is rain, and BR, that's a hard one until you get to learn that the mist looks like a baby rain, and that's why it's a BR, the baby rain. Then ceiling, that's your other very important piece of data. Broken at 800 AGL, it's always AGL here. Overcast 1200 AGL, and then cumulonimbus, that's the word you really don't want to see in the forecast. At least you don't want to fly into those, because we'll dig a little bit into those. The cumulonimbus clouds is your thunderstorm phenomena, which means a lot of updrafts, downdrafts, hail, very dangerous for flights. So that's like, let me throw in a question back at you, Alexei. Does it make sense? Would you be able to decode at least some of those words when you see it?
Yeah, I've actually seen this before. Some of these abbreviations I'm not familiar with, but it does make sense for the most part.
Awesome. Well, get used to it. Okay. Now, very similar format, but the TAF, the Terminal Airport Forecast. The difference in TAF is, well, it's looking in the future, also coded, and it covers airport within the 5-mile radius, 30-mile radius. Typically expected issued 4 times daily. Again, very similar format. Starts with a TAF, so you know what you're looking for, then airport, then time, then the winds, visibility, phenomena like rain in this case, broken clouds at 2,000 feet. And TAF typically has several time frames. So in this case, you have a from 10 UTC, and then separately from before that from 6 UTC.
Where's the time in the?
Good question. Yeah.
I see 0530 UTC.
0530, right. So that's the date when the forecast has been issued. But then this format here is the 1206, the 12th day of the month, to the 13th day of the month. So from 6 UTC to 12 UTC on the next day. It's kind of very long forecast.
Oh, okay.
That's one of the very standard format. And then later down in the same line, FM, from the 12-day 10 UTC, they expect, like, it's, I guess, look at it as a more detailed, more pointed in time forecast.
Okay, cool.
Takes a little bit of time to get used to that, but luckily a lot of apps that you will use, they have decoding capabilities, so it's a way to cheat out of those a little bit. Now, on to those convenience hacks. The text message that I told you about, it looks like that. You text the METAR and then airport, or TAF and airport, and immediately you get the text message with the current TAF and METAR for that airport. Pretty cool. Easy, simple. You don't even need to have a data plan. Now, if you do have a data plan, a small convenience hack from that I used called Aviation Weather in their basic free version of the app, you get a lot, almost enough. If you buy into advance, there are some extra features that I never used myself. But ability to sort by the nearby airports, and immediately you see even by color that's like, well, it's mostly green in the vicinity, and then you read into visibility 10 miles, clear, few clouds, 20,000, no big deal. So that one page on your phone, that's a good summary of what's going on at airports around you.
Nice.
Okay, so that's for convenience. Now we'll dive into more of weather details. I'll try to make it not too long, then we'll be happy to circle back to any details. But again, look forward for that advisory circular that I'll point on the last slide, because I enjoyed that read myself. It's a good collection of all kind of weather-related education that FAA nicely put together for us. But let's get back to the slides. PIREPs, pilot reports. You can submit one through Flight Service Station or online, many different ways. And again, the format is encoded. It could be a little cumbersome to read until you get used to them. There is a table with some of the qualifiers and acronyms. The idea, to put it simple, the probably main value is to report what pilot care the most, which is cloud layers and icing. Those are the top of the clouds are very hard to estimate for the radar services. So when the plane pierces through the clouds and comes out on top, they would report back with the cloud tops at a specific location. And then you can see them all either in a for-flight visually, or you can obtain them from a flight service station or the weather center, AWC, the website, or even air traffic control. If you're flying, like we did recently to Eugene, we're flying inside the clouds most of the time, really wanted to get on top of those clouds. So the simple questions like, hey, ATC, do you have any cloud tops reports in the area? And unfortunately, tops were too high for us to climb because of the icing. So there is a PIREP, the most accurate specific point in time, point in on the map report from a pilot who flew through that place. Okay, next one. NextRad. That is becoming a lot more useful, probably like in the last decade or so. It's rather new technology. The resolution of the radars grew, and also the means to distribute that data grew, including it is available on the full glass cockpits, even in general aviation. The Garmin G3X has it, and that's a pretty affordable piece of equipment that we see in general aviation. There are a lot of those high-resolution radars, and then all that data gets processed, combined, and distributed. Uses Doppler radar technology. The main risk on that is a delay, and delay can be as short as 5 minutes, can be as long as 20, 30, or possibly even more. And there are accidents in the history where somebody would try to fly around the weather using NextRad, but clouds move a lot faster than you could anticipate, so it's not a real time, but for the general situational awareness, that's an amazing service. So when you hear NextRad, think of those pictures that show precipitation locations, and the more yellow or red those are, the heavier the rain in that place is. Then let's go over a couple charts. Weather depiction, again, I don't want you to be too puzzled by them. Is this a map that you would look or have to look for any local pattern flight? Probably not. Are they cool to look at? Yeah. You see where the pressures are, the high pressure, low pressure, where the fronts are moving. On Aviation Weather website, you get a set of forecasts, so you can see how the fronts are expected to change every hour. Very easy to read graphical representation. Yeah, and that's probably all there is to be said about weather forecast. Now, so the next chart is the surface analysis. That one goes deeper and helps pilot to understand the underlying weather systems. You see the isobars, you see how the fronts are moving again. There's a lot that pilot can digest from this map, but this does take practice. At this stage of your learning, if you just know they exist and know what they mean, how to read them, that should be enough. Maps are super easily available through ForeFlight as well as the 1-800-WX Breathe website. Couple other charts. This one is real easy. In fact, you can build or even buy the METAR plot charts, where with colorful LEDs you'd show the METAR condition of specific locations in real time. Kind of cool. The red means IFR, green means VFR, and if you see that all of Oregon Valley is IFR, you're definitely not flying. So real simple, easy, and also, as all other charts, available in ForeFlight for free, well, assuming you have the ForeFlight itself. Next, winds and temperatures aloft. That is useful for many reasons, including the fact that you want to fly at the winds that are most favorable for you, tailwinds preferably, and that same table gives you the temperatures aloft. On a typical VFR day, that's a no problem. But when you have any clouds, any moisture in the air, you don't want to hit the freezing levels. The table down below, that gives you the spread of winds and temperatures. So for example, you see that at 9,000 you have a 0 temperature. So anything around that altitude has a risk of freezing, icing. And planes don't fly well in icing for sure. There are a couple rules that worth talking, at least talking, but eventually memorizing, that if wind is stronger than 99, then it simply doesn't fit in a format that they planned. In this case, the bearing needs that add the 50 operation. And then if the wind is greater than 200 knots, then it's simply shown as 99. So there's a little bit of magic to do with the decoding, but that only applies if winds are stronger than 100 knots. And calm, less than 5 knots, are shown as 9900. Okay, so to illustrate this rule of adding the 50, I just brought in this table. If you look at the lower right corner, the 73 is obviously not the heading. That would have been 730 degrees. This is where you need to subtract the 50 because the wind speed is above 99 knots. So what it reads really is a 230 wind direction at 106 knots, and the temperatures above 24,000 feet are always negative, so there is no minus sign because it's always negative, in this case minus 49. So in the table, the 730649 means winds at 106 knots, direction 230, and temperatures minus 49. That's how encoded it is, but again, you'll use it a few times, you'll get used, will become easy. Okay, next one. Now, those couple guys are definitely in every check right question, and those are important details. Air mets. So those are general meteorological events. There are 3 types: the Sierra, Tango, and Zulu. Sierra is a air met that describes instrumental conditions, and they're all nicely pictured on the map. AirMet Tango is the turbulence. Again, they're able to forecast where you would expect turbulence at what altitudes. And AirMet Zulu is the icing and freezing level forecasts. Typically, having an AirMet like a Sierra or Zulu, say, means that weather is less than ideal. And flying through AirMet Zulu in a aircraft that's not equipped for icing is not a smart move, to say the least. Now, the second type of urgent and important report is a SIGMET, which suggests a significant meteorological information. Those are issued as needed for severe weather. They don't have a special schedule, so basically when you do a briefing in for flight, there'll be a section where SIGMETs will pop up if they exist, and that means something is really risky for the flights. Convective SIGMETs, that is when you have a lot of updrafts and downdrafts, the thunderstorm activity. They are very dangerous events for the airplanes. And anything else significant, like even the volcano, ash, or super dense smoke, maybe, you'll get those in a form of a SIGMET. So you see a SIGMET, that's a big deal. You see AirMet, you still read into this, it could still be a big deal, but AirMets are more common, while SIGMETs are significant. If you remember those 2 things, you'll figure out the rest as you read more and more into the weather. So, with that, you can probably tell that I'm not going to the lowest level of details. There's no way I can do that even in 3 hours. But this one, the AC Advisory Circular 0-6B, amazing read. I think it's about 60-some pages long, but it goes into all kinds of details, starting from why we have weather, such as Earth gets a lot of sun radiation and heats up more than the ocean, and then the air starts moving, the cold air replaces the hot air, and it goes all the way through how the light reflects off the clouds and the mountain wave turbulence, and explains what means a stable atmosphere and unstable atmosphere. Very useful. It is one of the key advisories, and I would say it's a must read. You can get it in an audiobook format to make it a little easier, but I highly recommend reading that. Yeah, put it on.
The pictures.
There are some pictures, true, which help, right? But there is still a lot of reading. I believe it's a good read.
Awesome. Thanks.
So, and then once you'll become a private pilot, at some moment you will have to build your personal weather minimums, because very rarely weather is completely unflyable for a airplane. But every person, depends on experience, physiological limitations, would have some, and most importantly experience, would have their personal weather minimums. So everyone would be different, but someone would say, for example, I would not fly with wind more than 20 knots, crosswind component more than a certain number for a specific runway, maybe specific plane. Thunderstorm activity is generally required to avoid by 20 miles at least, because within 20 miles you're likely to hit hail at an altitude, and that is risky and dangerous. Density altitude, big deal, separate discussion. Basically, if the air is too hot and too thin, your airplane will fly as if it's a lot higher. So on a hot summer day, departing with a full load in a Cessna 172 could be very risky because of the density altitude. And you can find that very often in the METAR section. And the cloud ceiling, again, like above 3,000 foot, you're probably very safe. Would you fly if it's marginal without IFR rating? Probably not a good idea. So those are examples of personal weather minimums. I'm not saying that you have to develop them this early in the education, but I definitely recommend before becoming a independent and rated, certificated pilot, you can do that. So to wrap this up, the completion standards, like if you'd be taking this to a check ride, like what can you be expected out of this material? And I kind of glanced at this at the very beginning of the lesson, but once again, types of weather briefings, the abbreviated standard outlook, what they do and how detailed they are. Then METAR, TAFs, winds aloft, how to decode them, and again that trick with the adding 50, for example. Being able to read them, you'll definitely be reading a lot of METARs when you prepare for flights, and you'll definitely be given one on a check ride. Types of weather charts available to pilots, again, there are a lot. They share a lot of the common information between them, but they all have some unique purpose and feature in them. Sources available to pilots both in flight and on the ground. Websites, even the text message, real easy and free to use. Common aviation hazards, we didn't go deep, but once you'll read that AC66, you'll learn about the wind shear, risks of what are coming from the thunderstorms, risks from the icing. All those three are very big aviation hazards, for example. Personal weather minimums, definitely develop and discuss them regularly. Depends on how often one flies. He would rely more on advice of an instructor or a peer, someone with more experience. Now, this weather for the cross-country flight would step up to a little bit higher level. You have to be able to look at a proposed flight and then, using all available resources, analyze if it's a good flight, what are the risks, what kind of altitudes, and basically correlate all weather information to make a go, no-go decision. just as you would if you and me would fly to the Pacific City. Today we'll look outside, it's not real pleasant, but then we'll go get taps and METARs and formally make a decision if that's a good idea to go. Well, that's all I had for today. Being the first introduction to weather, I think that should keep you pretty full. But again, weather is a deep topic, and there is a lot more to the weather that you'll be learning in the coming months. That's all.